All right, so everybody's probably wondering, when are we going to actually write this VECOP function? Let's see how it's done. There's only one thing we still need to do, and that's I need to tell you what is the desired behavior of the VECOP function. We wouldn't know what to program if we don't know what its actual goals are. That's what I'll tell you here. The VECOP stands for vector operations, and it's defined in the following way. The inputs are supposed to be a 3x1 real numerical vector v. On this slide I'll label its components v1, v2, and v3. Also a real numerical vector w with the components labeled similarly. And the outputs are supposed to be the 1x1 numerical dot product of v and w, which is defined as this summation v1w1 plus v2w2 plus v3w3. And the second output should be the 3x1 cross product of v and w, v cross w, which is defined in terms of the components this way. Now that the desired behavior is clearly described, it's very easy to program this VECOP function. Let's do it. Here it is. We have the function declaration line, and then what we have is 5 lines which are logically correct expressions and assignments that simply define and compute the output variables using the values of the input variables. Looking at the line that defines the dot product output dp, we see that it uses element-wise multiplication of the two vectors followed by the sum operator, which sums up the components. That results in the calculation that is the dot product. For the cross product, it starts by initializing the cross product to be a vector of zeros of the correct dimension, and then simply 3 assignment statements that assign the correct values to the elements of CP in terms of the elements of V and W via the formula for cross product. Let's try this out in Matlab. Let's open the editor, and here is the VECOP function. 5 lines as we discussed. First the dot product, then allocating the space for the cross product, and finally making all 3 of the cross product calculations. In the workspace, let's create 2 vectors, v1 and v2, and then we'll call VECOP, computing the dot product v1 dot v2 as well as the cross product of v1 cross v2. We run that command. D is the number -1 and C is -511. You can verify that these are the correct values for the dot product and cross product. So there you have it. We've written our first M function. The name of the function is VECOP. We saved it in a file called vecop.m. It has these 5 lines of instructions which end up mapping the input variables into the output variables by doing the correct calculations. Now it's just a matter of using our imagination to write even more interesting and useful functions.